Okay, you can't add these two fractions until they have a common denominator. So let's go ahead and find the common denominator. Let's get started. It's a fraction problem, everybody's favorite. You cannot add fractions or subtract fractions unless their denominators are the same. So there's the problem up there. Going to get some working room here. So we have 9/14, an awkward fraction, plus another awkward fraction, 2/21. So what we're going to do is build a denominator that we can change this into whatever the new denominator is, and this as well, legally, right, through the laws of algebra. So we're going to build a new denominator. It goes by many names: least common denominator, whatever you want. But the denominator has to be the same for both of these fractions before we can add them. And we have to change them legally. I say that many, many times. And we're going to factor. Okay, factor takes on a lot of different words in an algebra class. Factor is a noun, as in 3 and 4 are factors of 12. To factor is a verb, that is the infinitive version of to factor. That means to break a number down into the product of different multiplied numbers. And those numbers, when you multiply them, are factors. So factor just basically means multiply. Either to be multiplied, or you're going to multiply it by, or just think multiplication. So whenever you hear factor, multiplication. Sweeping a nation. All right. So you're going to factor the denominators, right? You got 14. It's 2 times 7. Through the magic of computers. Kabam. So we broke them down. 2 times 7, 3 times 7. So a common denominator has to have all the factors of every other denominator up there. Okay, so we need to get all the factors into this new denominator. But if there's a shared factor, as in our case it's going to be the 7, right? 7's in both of them. You're only going to bring that down once as a factor. But all factors are going to come down there. So let's go ahead and do this. Just like the kid says, let's do this. All right. So there's going to be a 2. There's going to be a 7. There's going to be a 3. And there's already a 7 here, so we don't need to do that one. Okay, so let me put in my multiplication thing. The little dots represent multiplication, in case you forgot or something. But all right, so I'm going to work on this first one here, 9/14. I'm going to spread out the fraction bar. So I look at this denominator. It's got a 2 of a factor, a 7 is a factor, so it's missing the 3. So I'm going to put in a factor of 3. One of the most important rules in all of algebra is if you put in a factor on a denominator, you have to put in the exact same factor on the numerator, and vice versa. If you put one on the numerator, you have to put the exact same factor on the denominator. Now that's only true for multiplication and division. Got it? So what we do to the bottom, we have to do to the top. I want you to see what we're really doing here. So 3 divided by 3 is simply 1. 1 as a factor never changes anything. So this is the legal way to do what we call expand a fraction. It's the opposite of reducing. We're expanding it. And let's just do what we do on top, right? 9 times 3 is 27. So we're going to repeat the process with the 2/21 on this side. Spread out the division bar, fraction bar. And I see it's got a 3 and a 7. So it looks like it's missing a factor of 2 on the bottom. I'm going to add that in. So whenever I multiply on the bottom of a fraction, I have to multiply on the top. Same. And then I just multiply 2 times 2, and I get 4. So I'm ready to go. Right? I have the common denominator. Order does not matter in multiplication, right? 2 times 7 times 3 is going to be the same as 2 times 3 times 7. Use your calculator if you don't trust me. So now we have just the numerators being added over the common denominator. Common denominator. I need some working room here. It's a mess. So 27 plus 4 is 31. And then you can just finally multiply this out. 2 times 7 is 14. Times 3 is 42. So that looks like the answer. Let's check the quiz. That looks like it to me right there. And that is it. MGZ out.